We have a problem with the way we look at the universe. We have convinced ourselves that the most dangerous objects in the sky are black holes. We define them as bottomless pits where gravity quietly erases everything. It is a convenient theory. It tells us that destruction is passive. It tells us that things just go away. But there is a growing group of astrophysicists who believe that this picture is not just wrong. It is physically impossible. They argue that the math of the universe forbids holes. Instead, what we are seeing in the dark are actually solid, pressurized objects. They are called Gravastars, and the difference is critical. A black hole is a grave. A Gravastar is a fully primed bomb. It looks like a hole from the outside, but inside, it is filled with the same dark energy that is tearing our galaxies apart. If this theory is correct, we haven't been looking at empty wells. We have been staring down the barrel of a loaded weapon that has been pointed at us since the Big Bang. Why would anyone invent such a terrifying alternative? Because the standard black hole model is broken. And it has been broken since the day Einstein's equations first predicted it. The problem is the singularity. You have heard this word 1,000 times in science fiction. We are told that at the center of a black hole, a massive star gets crushed down into a point of infinite density and zero size. But if you are an adult living in the real world, you know that infinity is not a number. It is an error. In physics, when an equation gives you infinity, it doesn't mean you found something cool. It means your calculator just broke. It means the theory has failed to describe reality. You cannot pack a sun into a zero-dimensional dot any more than you can divide by zero on your phone. Nature has limits. The laws of physics have to stop the collapse somewhere. In 2001, physicists Pavel Mazur and Emil Mottola proposed the fix. They looked at the collapsing star and asked a simple question. What actually happens to a material when you squeeze it too hard? Think about water. If you lower the temperature, water doesn't just get colder and colder forever. Eventually, it hits a critical point, 0 degrees, and it snaps. It undergoes a phase transition. It changes its fundamental structure from a liquid to a solid. It becomes ice. Mazur and Mottola argued that the vacuum of space works exactly the same way. When a star collapses, gravity squeezes the fabric of space-time so hard that it hits a critical limit. It doesn't shrink to nothing. It snaps. It freezes. The vacuum undergoes a phase transition and turns into a rigid, impenetrable shell. The collapse stops dead. The star doesn't become a singularity. It becomes a hard sphere, a bubble of crystallized vacuum. This solves the math perfectly. No more infinity, no more broken physics. But it creates a physical nightmare. Because now, instead of a magical doorway to nowhere, you have a solid wall in the middle of space. And God help anything that runs into it. So, if we strip away the romantic idea of the bottomless pit, what are we actually looking at? You need to completely reconfigure the image that Hollywood has planted in your head. For decades, we have pictured a black hole as a funnel, a whirlpool, or a drain in the bathtub of the cosmos. We imagine a gentle slope that leads down into a mystery. But a Gravastar is not a funnel. It is not a drain. It is a bubble. Imagine a perfect solid sphere floating in the absolute silence of space. From a distance, it looks pitch black, exactly like a black hole, because its gravity is still intense enough to trap light in a tight orbit around it. If you took a photograph of it with a standard telescope, you would see the same dark shadow and the same ring of fire that we see in our textbooks. But the geometry, the shape of the thing, is a lie. A standard black hole is defined by an event horizon. In physics, an event horizon is not a physical object. It is a ghost. It is just a line in the sand, a mathematical point of no return where space falls inward faster than light. You can fly through an event horizon the same way you fly through a cloud. But here is the question you have to ask yourself. What if the universe does not build ghosts? What if it only builds matter? A Gravastar does not have an event horizon. Instead, It has a surface, a physical, tangible, hard skin. This is the most disturbing part of the theory because we are used to the idea that deep space is empty. We accept that stars are made of plasma and gas, things you can fly through if you have a strong enough shield. But a gravastar is a shell of exotic matter that acts like a solid concrete wall. It is effectively a tank, a super dense armored container designed to hold the pressure of a collapsing reality inside. And because it has a surface, it changes the rules of engagement entirely. You do not fall into a gravastar in the way you fall into a dream or a hole. You fall onto it. Can you see how that distinction changes your death? From a mysterious journey into a messy, violent industrial accident? We are no longer dealing with a magic portal to another dimension. We are dealing with a sealed bank vault that strictly forbids entry. The door is not open. The door does not exist. Let us simulate exactly what happens when you try to interact with this object. Let us say you are an astronaut and you decide to jump into what you think is a standard black hole. In the old story, the one you learned in school, you cross the event horizon and you do not feel anything special at that exact moment. You just drift into the darkness, deeper and deeper, until the tidal forces gently stretch you apart like taffy. It is a quiet, lonely way to go. But now, let us run the simulation with the Gravastar model. You fall toward the dark sphere. Gravity grabs you. But this is not Earth gravity. This is the gravity of a million suns. It accelerates you to speeds that the human mind cannot comprehend. You are moving at 99.9% of the speed of light. You possess the kinetic energy of a planetary impact. You watch your altimeter drop. You approach the point where the horizon should be. You expect to pass through it into the shadows. You brace for the silence. But what happens when the road simply runs out? There is no horizon. There is a wall. The impact is instantaneous. You do not slip through into a wonderland. You simply collide with the hardest object in the known universe while moving at relativistic velocity. Think about a fly hitting the windshield of a jet aircraft. Now imagine the windshield is made of crystallized space-time, and the fly is moving fast enough to circle the Earth 7 times in a single second. That fly is you. Did you really think you would have time to scream? There is no time to feel pain. There is no time to realize your mistake. The electrical signals in your nerves travel at a few hundred miles per hour, but you are hitting the wall at 670 million miles per hour. The crash happens thousands of times faster than your brain can process the concept of ouch. You do not just break bones. You do not just splatter like a bug. You undergo total atomic dissociation. The sheer force of the impact shatters the bonds between your protons and neutrons. The structure of your biology is erased from the universe in less than a nanosecond. This is the reality of a solid singularity. It turns the cosmos from a place of mystery into a place of blunt force trauma. You stop existing before you even know you have stopped moving. We need to look at the physics of that impact because it reveals something horrifying about the temperature of these stars. We usually think of deep space and black holes as cold places. Absolute zero, the frozen dark. But if gravastars are real, that is another lie. When matter hits a solid surface at relativistic speeds, that kinetic energy cannot just disappear. The law of conservation of energy says energy must go somewhere. In a black hole, the energy is swallowed by the abyss and lost to our sight. But a gravastar has no abyss. It has nowhere to hide the energy. So where does all that violence go? It converts. It turns your mass and your speed into heat. Your body, your spaceship, and everything you brought with you is instantly converted into a flash of gamma rays and thermal radiation. You become a nuclear explosion on the skin of the star. This means that gravastars are not cold. They are hot. Incredibly, impossibly hot. The surface is a roiling inferno of plasma, formed from the debris of everything that has ever fallen onto it. It is not a trash can for the universe. It is a crematorium. It burns matter to ash and plasters that ash onto its hole. If you were watching this from a safe distance, you would not see a person disappearing into a mystery. You would see a brief, violent flash of hard radiation as the hole claimed another victim. It is a brutal, efficient disposal system. And this thermal glow is one of the key ways we might actually be able to prove they exist. While astronomers are looking for dark silence, they should be looking for these faint, hot screams of dying matter. We might have already seen them and mistaken them for something else, dismissing the evidence of a cosmic execution because we were too busy looking for a magic trick. Every time we see a strange gamma ray burst in the sky, you have to ask yourself, is that a star being born, or is it a star slamming into the concrete wall of a Gravastar? But what is this wall actually made of? It is a question that breaks the brain of a classical physicist. What kind of material can stop a collapsing star in its tracks? What material is strong enough to hold back the crush of gravity that should technically be infinite? It is not steel. It is not rock. It is not even neutron star matter, which is already incredibly dense. It is something called a Bose-Einstein Condensate. This is the fifth state of matter. We create it in laboratories on Earth by cooling atoms down to almost absolute zero. At that temperature, atoms start to act very strangely. They lose their individual identity. They stop bouncing around like chaotic billiard balls and lock together into a single, giant quantum wave. Imagine an army. In a normal gas, the soldiers are running around in random directions, bumping into each other. That is normal matter. But in a Bose-Einstein condensate, every soldier stops, turns, and marches in perfect synchronization. They become one single entity. A Gravastar is essentially a giant, planet-sized drop of this superfluid. Because it is a quantum object, it has zero viscosity and zero friction. It flows perfectly. But, and here is the paradox, it possesses absolute rigidity against compression. You cannot squeeze it. It is the hardest substance physically possible. Think about the implications of that. The wall you just hit is not made of stuff in the way you understand matter. It is made of a single quantum equation made manifest. It is a shell of pure order. It is a single giant atom the size of a city. And that is why it is so dangerous. It does not bend. It does not break. It does not possess weak points or cracks. It just waits for you to break against it. This substance represents the ultimate triumph of quantum mechanics over gravity. Gravity wants to crush everything to a point, but this condensate refuses to move. It is the irresistible force meeting the immovable object, and in this version of physics, who do you think wins? The immovable object wins every time. Here is the detail that makes the engineering of a Gravastar truly haunting. When I talk about a wall or a shell, you probably imagine something thick. You imagine the crust of a planet, miles of rock protecting the core, or you imagine a fortress wall, thick and heavy. But the mathematics of the phase transition says no. The shell of a Gravastar is incredibly thin. How thin? The calculations suggest it is likely only 1 Planck length thick. To give you a sense of scale, a Planck length is a decimal point followed by 34 zeros and a 1. It is the smallest possible distance in the universe. It is the pixel size of reality. It is billions of times thinner than a single proton. You are separated from the interior not by a fortress, but by a membrane that is effectively two-dimensional. It is a razor-thin veil of space-time. But because of the extreme density, that veil is stronger than 1,000,000 miles of lead. There is something deeply unsettling about this fragility. It means the only thing standing between our universe and the chaos inside the star is a soap bubble made of math. Does that make you feel safe? It feels precarious. It feels like it should not hold. It implies that the boundary between existence and destruction is not a wide buffer zone, but a knife edge. We are walking on a sheet of ice that is infinitely thin, trusting that the laws of quantum mechanics will keep it from cracking. It is the ultimate tension, the heaviest object in the world, held back by the thinnest wall in the world. And as we will see later, That trust might be misplaced, because if that thin shell ever fails, the monster inside will not just kill the astronaut, it will kill the vacuum itself. Why would the universe go through the trouble of building such a complex, weird structure? Why build a pressurized bubble instead of just letting gravity win and making a hole? The answer lies in the one law of physics that rules them all: entropy. In simple terms, entropy is a measure of disorder. It is a measure of how messy a system is. If you drop a glass on the floor and it shatters, entropy increases. The order of the glass is gone, replaced by the chaos of shards. Nature loves entropy. It usually wants things to fall apart. But here's the problem with the standard black hole model that has bothered physicists for 50 years. A black hole has massive, almost infinite entropy. It is the ultimate garbage dump of the universe. Stephen Hawking spent his entire career trying to figure out how a black hole handles this chaos without breaking the laws of thermodynamics. It is a messy, ugly solution. But a Gravastar is different. A Bose-Einstein Condensate is not messy. It is a state of near-perfect order. It has very low entropy. If the universe is trying to be efficient, why would it create a trash can when it could create a filing cabinet? The Gravastar theory suggests that the cosmos prefers to build safes rather than shredders. It wants to keep the matter, just in a different form. It organizes the chaos of a collapsing star into a rigid, structured shell. This implies that the universe is not indifferent to the death of stars. It actively resists the chaos. It builds these structures to preserve order in a cosmos that is dying to become disordered. But you have to ask yourself, is a universe that preserves everything actually better than one that destroys it? Or is there something terrifying about a reality that refuses to let anything go? A black hole is a death. A Gravastar is a hoarding mechanism. It collects the corpses of stars and stacks them in neat, cold piles. It is a graveyard that never rots. This idea of preservation solves one of the biggest headaches in modern science: the information paradox. This is a nightmare scenario that keeps quantum physicists awake at night. Quantum mechanics has a sacred rule called unitarity. It states that information, the data that describes every particle in your body, can never be destroyed. Even if you burn a book, the information is theoretically still there in the ash and the smoke. But if you fall into a standard black hole, and that black hole eventually evaporates via Hawking radiation, the information is erased. It is gone. This breaks physics. It implies that history can be deleted. But with a Gravastar, there is no paradox. Why? Because you never fell in. When you hit that Bose-Einstein shell and vaporized, your energy and your quantum information did not disappear. It was plastered onto the surface. You became part of the shell. Think about what that means. A Gravastar is technically a giant hard drive. It stores the record of everything it has ever killed. Every star, every planet, every unlucky astronaut that has ever crashed into it is encoded in the phase transition layer of the shell. You are not lost in the dark. You are archived. You become a permanent line of code on the surface of a dead star. The universe effectively takes a snapshot of you at the moment of your destruction and freezes it forever. It is a form of immortality, I guess, but do you really want it? It is the immortality of a fly trapped in amber. You are preserved, yes, but you are not alive. You are just data. And as these stars grow older and eat more matter, they become libraries of the dead, carrying the history of the universe on their skin, waiting for someone to read the tragic story written in their atomic structure. There is one last cruelty to this death that we need to address. It concerns the flow of time itself. We know from Einstein's general relativity that gravity warps time. The closer you get to a massive object, the slower time moves for you relative to the outside world. This is not a theory. We use it every day to calibrate GPS satellites. But near a Gravastar, this effect becomes extreme. If you were falling toward the shell, time for you would pass normally until the moment of impact. But for someone watching you from a safe distance, say, your mother on a spaceship far away, the scene would look horrifyingly different. As you approach the shell, she would see you slow down. Your movements would become sluggish. The light coming from your ship would turn red. And right before you hit the wall, you would appear to freeze. Because the gravity at the surface is so intense, the light you reflect takes an eternity to climb out of the gravity well. To the outside observer, you never actually hit the wall. You just fade into a frozen, ghostly image that hangs there forever. You become a statue, a monument to your own death. Long after you have been vaporized and turned into thermal energy, your image remains stuck to the sky, screaming in silence. Imagine the horror of that. You are gone, obliterated in a nanosecond. But the universe keeps your ghost alive, forcing everyone else to watch your final moment for billions of years. It creates a disconnect between reality and observation. You are dead, but you look alive. It is the ultimate cosmic gaslighting. Does the universe enjoy tormenting the observer? Or is this just the cold, unfeeling side effect of bending light until it breaks? We have spent a lot of time talking about the shell, the wall, the crash, the archive. But a shell has to contain something. A bubble cannot exist without pressure from the inside to hold it up. If gravity is pulling everything inward with the weight of 1,000,000 suns, what is pushing back? In a normal star, the outward pressure comes from nuclear fusion, explosions pushing against gravity. But a dead star has no fusion. It has no fuel. By all rights, the shell of the Gravastar should collapse instantly under its own weight. It should crumble into a singularity in a fraction of a second. But it doesn't. Something is holding up the ceiling. Something incredibly powerful is trapped inside that Bose-Einstein shell, pushing outward with enough force to fight the gravity of a supernova. This brings us to the most terrifying part of the anatomy of this monster. We are going to mentally drill through the shell. We are going to pass through the wall of death, past the layer of crushed atoms, and enter the interior. What do we find? We do not find a ball of iron. We do not find a churning ocean of plasma. We find a vacuum. But it is not the vacuum you know. It is not empty space. It is a space filled with a pressure that defies common sense. In our world, pressure pushes things together. But inside a Gravastar, the pressure is negative. It is a suction that blows outward. It is a zone where gravity works in reverse. So, what exactly is filling this void? What substance has the power to tell gravity to go to hell? The substance inside the shell is dark energy. Pure, concentrated dark energy. You have heard this term before. Dark energy is the mysterious force that makes up 70% of our universe. It is the invisible hand that is stretching space, pushing galaxies away from each other, and accelerating the expansion of the cosmos. In the open universe, dark energy is thin and weak. It is spread out. But inside a Gravastar, it is packed tight. It is condensed. The interior of this star is a reservoir of the most destructive force in physics. This changes the definition of the object entirely. A black hole is a drain. It removes things from reality. A Gravastar is a battery. It stores the energy that destroys reality. Think about the engineering of this. You have a shell of matter trying to collapse inward, and a core of dark energy trying to blow outward. The star is locked in a permanent, violent standoff. It is a balance of terror. The only reason it doesn't explode is that the shell is too strong. The only reason it doesn't collapse is that the core is too angry. It is a bomb that has been armed but not detonated. And this means that the universe is dotted with billions of these pressurized containers. Every single one of them is holding a pocket of anti-gravity that wants to rip the fabric of space apart. Do you feel safer knowing that? Or do you feel like you are walking through a munitions depot where the explosives are disguised as holes in the ground? We used to fear the dark because we thought it was empty. Now we have to fear it because we know it is full. And what happens if one of these containers springs a leak? If we could somehow survive the impact with the shell, If we could magically pass through the wall of Bose-Einstein Condensate without being vaporized, we would enter a region of space that effectively does not belong to our universe anymore. The interior of a Gravastar is not just a room filled with dark energy. It is a completely different geometry of existence. Physicists call this de Sitter space. To understand why this is terrifying, you have to understand what time looks like in our normal world. Out here in the universe, you know, time is a river. It flows, it has a direction. We have a past, a present, and a future because the universe is filled with matter that evolves. But inside the Gravastar, the rules change. The interior is dominated by a cosmological constant that is so high that it drowns out everything else. In de Sitter space, the very concept of history dissolves. There is no entropy generation inside the core because there are no particles to become disordered. There is no ticking clock because there are no events to mark the passage of seconds. It is a zone of absolute terrifying stasis. Imagine being trapped in a room where tomorrow is physically impossible. You are suspended in a state of eternal, frozen expansion. The dark energy pushes outward with a constant, unyielding pressure that never changes, never fluctuates, and never ends. It is a vacuum that has been stripped of all potential for change. This creates a disturbing paradox. The Gravastar is an object that exists within our timeline. It rotates, it moves through galaxies, it ages, but its interior is severed from causality. It is a bubble of eternity floating in a sea of temporary moments. If you were trapped inside, you would not die of old age. You would not rot. You would simply exist in a single, stretched out moment of now that lasts for trillions of years. Is there a hell more potent than a place where time refuses to pass? We usually fear death because it is the end of time, but the interior of a Gravastar suggests that there is a fate worse than death: the inability to reach the end. It is a prison cell where the sentence is not finite, and it is not infinite. It is simply outside the jurisdiction of time itself. The existence of this repulsive core forces us to confront the biggest lie we have been told about the architecture of the cosmos. The standard black hole model is famous for its center, the singularity. We are told that gravity pulls everything into a single point of infinite density. It is the ultimate crunch. It is a needle that punctures the fabric of reality. But the Gravastar model presents us with the exact opposite geometry. It is an anti-singularity. Because the interior is filled with dark energy, which exerts negative pressure, the center of the star does not pull, it pushes, it repels. If you were at the exact center of a Gravastar, you would not be crushed. You would be torn apart by the expansion of space itself. This solves the mathematical error of infinity that plagues the black hole theory. Nature does not have to deal with a point of zero size. Instead, it spreads the energy out smoothly across the entire volume of the interior. The core is regular. It is smooth. It is mathematically perfect. But this perfection is cold comfort to the human mind. We can understand the violence of a crush. We understand a car crusher or a trash compactor. But can you understand a violence that is based on pure, smooth repulsion? The Gravastar replaces the sharp, stabbing death of the singularity with a suffocating, expansive death. It is the difference between being stabbed by a knife and being blown apart by a shockwave. By removing the singularity, the Gravastar removes the only exit from the equations. In a black hole, the singularity is a breakdown where physics stops, and maybe, just maybe, something else begins. But in a Gravastar, physics never stops. It just loops. The dark energy pushes against the shell pushes back, and the cycle continues forever. There is no breakdown. There is no magic escape hatch. There is only the pressure. The universe did not make a mistake when it built these things. It built a perfect trap. And the scary question is, why does nature need a trap that never breaks? We must now ask how this monster survives. A star, even a dead one, is an engine. It interacts with its environment. And the way a Gravastar interacts with the universe is through a process of consumption. that is fundamentally different from a black hole. A black hole just accumulates mass. It gets heavier. A gravastar, however, acts like a parasite that converts its host into something else. When matter, gas, dust, or an unlucky planet falls onto the shell, it hits that hard surface and vaporizes. We know this creates heat. But what happens to the mass? The mass is absorbed into the energy of the shell, and as the shell gains energy, the balance of the star shifts. To maintain equilibrium, the interior volume of dark energy must grow. This means that every time a gravastar eats a star, it converts that ordinary matter, the stuff of life, atoms, and chemistry, into more vacuum energy. It is a machine that turns something into nothing. It eats reality and excretes void. Think about the implications of that mechanism. It is effectively a virus of space-time. It takes the complex, beautiful structure of baryonic matter and dissolves it to build a bigger bubble of empty, repulsive force. The more it eats, the emptier it gets. This turns the gravastar from a passive object into an active threat to the composition of the universe. It is slowly, methodically replacing the useful matter of the cosmos with pockets of unusable, hostile dark energy. If you look at a galaxy, you see billions of stars shining in the dark. But if this theory is right, there are millions of these parasites hiding among them, slowly chewing holes in the galaxy, turning the star stuff into vacuum stuff. It is a form of cosmic cancer. A cancer does not just kill the host, it rewrites the host cells to serve the tumor. The gravastar rewrites the laws of matter to serve the vacuum. Does it not feel like we are living in a body that is fighting an infection we cannot even see? Why would the laws of physics allow such a monstrosity to exist? Usually nature eliminates things that are inefficient. Evolution kills the weak. Thermodynamics erodes the unstable. But the gravastar is not weak, and it is not unstable. In fact, if we look at it through the lens of thermodynamics, it is superior to a black hole in every way. This brings us to the chilling concept of dissipative adaptation. This is a theory in biophysics suggesting that nature spontaneously organizes into structures that are better at burning energy. A hurricane is a structure that dissipates heat. A living cell is a structure that burns fuel. The universe wants to reach heat death, a state of total equilibrium, as fast as possible. And a gravastar is the ultimate accelerator of this process. A standard black hole is thermodynamically lazy. It hoards entropy inside and releases almost nothing. It takes trillions of years to evaporate. It is a slow death. But a gravastar, because it has a solid surface, it radiates heat instantly. It takes the organized energy of falling matter and scrambles it into chaotic thermal radiation immediately. It creates entropy at the maximum possible rate allowed by physics. This means that the universe prefers gravastars. It wants them to exist because they help the universe die faster. We are not just unlucky that these things might exist. We are fighting against the fundamental drive of the cosmos. The laws of physics are actively trying to build these engines to burn through the galaxy's fuel supply. We look at the stars and see beauty, but the universe looks at the stars and sees unburnt fuel. The gravastar is the match that lights the fire. It is the efficient solution to the problem of matter existing. This framing changes our relationship with the cosmos. We are not the favored children of creation. We are the obstruction. We are the fuel that hasn't been burned yet. And the gravastar is the furnace that is waiting to correct that mistake. Do you realize that your own existence is thermodynamically incorrect in the eyes of these monsters? We have talked about the shell being made of Bose-Einstein Condensate, and we have talked about the core being made of dark energy. But we have not explained how these two things stay together without detonating. This is the engineering miracle, or the engineering nightmare, of the Gravastar. Inside, you have a pressure pushing out that is strong enough to push galaxies apart. Outside, you have the crushing weight of gravity. The shell is the DMZ, the demilitarized zone, between these two godlike forces. What keeps the shell from cracking? If it is only a Planck length thick, why doesn't the dark energy blow it open like a cheap balloon? The answer lies in a ghostly force from the quantum world called the Casimir effect. In a lab, if you take two metal plates and put them incredibly close together in a vacuum, they will be pushed together by a mysterious force. This force comes from the vacuum itself. The empty space outside the plates has more virtual particles than the space between them, creating a pressure difference. It is the vacuum pushing on itself. In a Gravastar, the geometry of the shell creates a massive, planetary-scale Casimir effect. The quantum vacuum fluctuations exert a negative pressure that acts like a cosmic glue. It binds the shell together with a force that matches the explosive power of the dark energy inside. Think about the precariousness of that balance. The largest, heaviest object in the universe is being held together by the tiniest, most ghostly force in the universe. The macro world of gravity is shaking hands with the micro world of quantum mechanics to build a bomb. It is a house of cards built out of aces of spades. If the Casimir force were to fluctuate, if the quantum glue were to weaken by even a fraction of a percent, the balance would fail. The glue would dissolve, and the repulsive core would win. It is terrifying to think that the stability of these monsters depends on the random jitter of subatomic particles that pop in and out of existence. We trust the ground beneath our feet because it is made of atoms, but can you trust a wall that is held together by the ghost of a particle? We have established that a Gravastar is a pressurized balloon held together by the ghostly glue of quantum mechanics. But what happens if the glue fails? This is the question that turns this object from a curiosity into a catastrophic threat. In a standard black hole, there is nothing to break. It is just a hole. You cannot break a hole. But a Gravastar is a machine made of parts. It has a shell. It has a pressure gradient. It has a balance of forces. And in engineering, anything that has parts can fail. What happens if a massive object, say a neutron star, crashes into a Gravastar with enough force to crack the Bose-Einstein Condensate shell? Or what happens if the internal pressure of the dark energy grows too high for the Casimir force to contain? The result is not a collapse. It is the opposite. It is a rupture. Remember, the core is filled with repulsive energy that wants to expand. If the containment shell is breached, that energy is unleashed. It would be like popping a balloon, but the air inside the balloon is the same stuff that caused the Big Bang. The Gravastar would not implode. It would detonate. The stored vacuum energy would rush outward, tearing through the galaxy at the speed of light. It would be a localized recreation of the birth of the universe, a bubble of rewriting physics expanding outward, unmaking everything it touches. Do you understand the scale of that danger? We are worried about asteroids hitting Earth. We are worried about the sun dying. But those are local problems. A Gravastar rupture is a structural failure of space-time itself. It implies that these stars are actually dormant volcanoes. We're sitting next to them, warming our hands by their gravity, assuming they are stable graves, while in reality, they are ticking down to a phase transition that could wipe out a sector of the galaxy. Are we confident enough in our math to say that the shell is unbreakable? Or are we just hoping that nothing hits them hard enough to pull the pin? If these monsters are real, and if they are so dangerous, why haven't we seen them? Why do every textbook and every astronomer talk about black holes instead of Gravastars? The answer lies in the terrifying efficiency of their disguise. Nature has built the perfect camouflage. To understand this, you have to look at the math of gravity outside the object. Einstein's general relativity gives us a formula called the Schwarzschild metric, which describes how gravity bends space around a massive object. For a black hole, this metric works perfectly all the way down to the event horizon. Here is the trick. For a Gravastar, the metric is exactly the same. Outside the shell, gravity behaves identically. Light bends the same way, time warps the same way, planets orbit the same way. If you were floating in a spaceship orbiting a Gravastar, your instruments would tell you that you are orbiting a black hole. There is absolutely no difference in the gravitational signature until you are literally touching the surface. This is an optical illusion of cosmic proportions. It means that a Gravastar can hide in plain sight. When we look at the center of our own galaxy, at Sagittarius A, we see stars orbiting a heavy, invisible object. We assume it is a supermassive black hole because that is the story we know. But we have never seen the hole. We have only seen the gravity. That invisible giant could easily be a supermassive Gravastar, a balloon of dark energy 4 million times the mass of the Sun, and we would have no way of knowing the difference just by looking at the orbits. It is standing right in front of us, wearing a mask of darkness. How many of the black holes we have catalogued are actually imposters? Is it possible that the universe is teeming with these bombs, and we are too blind to see through the disguise? We are like a man looking at a field of landmines and calling them potholes, because they look similar from a distance. The ignorance is comfortable, but the reality is underneath the dirt. So, how do we strip the mask? This is the detective story of the century. We cannot use normal telescopes. Optical telescopes use light, and as we just established, the gravity of the object traps light in a way that hides the surface. Even the famous Event Horizon telescope image of the M87 black hole, that blurry orange donut that made headlines, does not prove it is a black hole. Calculations by theoretical physicists show that a Gravastar would produce an almost identical shadow. It would have a photon ring and a dark center, just like the picture. Our eyes are useless here. Light is a liar. To find the truth, we need a sense that can penetrate the darkness. We need to stop looking and start listening. Imagine you are in a pitch-black room. You cannot see anything. But there are two massive rhinoceroses in the room with you. How do you know where they are? You wait for them to crash into each other. When they collide, you will feel the floor shake. You will hear the thud. In space, the floor is the fabric of space-time itself. When massive objects collide, they do not just make a splash in the light, they make a splash in gravity. They send out ripples that stretch and squeeze the universe itself. These are called gravitational waves. For the first time in human history, we have the technology to feel the floor shake. This is our only hope. If Gravastars are real, they will not be found by looking at them. They will be found by listening to the sound of them dying. We have to close our eyes to see the monster. But the question is, do we know what a monster sounds like? To listen to the universe, humanity built the most sensitive machine in the history of our species. LIGO, the Laser Interferometer Gravitational Wave Observatory. This machine is a testament to our desperation to know the truth. It consists of two 4-kilometer-long tunnels arranged in an L shape. We shoot lasers down these tunnels and bounce them off mirrors. If a gravitational wave from a distant collision passes through the Earth, it stretches space by a tiny fraction. One tunnel gets longer, the other gets shorter. How small is the change? We are measuring a change in distance that is smaller than the width of a proton. In fact, it is 1,000 times smaller than a proton. It is the equivalent of measuring the distance to the nearest star and being accurate to the width of a human hair. That is how quiet the universe is. But with this machine, we can hear the collision of black holes billions of light years away. When we turned it on, we expected to hear the standard story. We expected to hear the simple, clean death of stars falling into the abyss. We wanted confirmation of Einstein's theory, but science rarely gives you what you want. It gives you what is there, and what is there might be more complex than a simple hole. LIGO gives us the ability to touch the physics of the collision. It allows us to feel the texture of the objects crashing. Are they soft? Are they hard? Are they empty? Are they solid? For the first time, we can test the hardness of the dark. We are reaching out into the void with a laser microphone, waiting for the universe to whisper its secrets. But before we can catch a Gravastar, we have to know what a standard black hole sounds like. We need a baseline for the silence. What does a black hole sound like when it dies? This is the control group of our experiment. When two black holes spiral toward each other, they create a specific wave pattern. It is called a chirp. As they get closer, they spin faster, and the frequency of the wave goes up. And then they merge. They touch. And in the standard model, this moment is defined by the event horizon. Because the event horizon is not a solid surface, there is no crash. There is no clang of metal on metal. It is two bottomless pits merging into one bigger bottomless pit. The horizons swallow each other, and crucially, any gravitational waves that go into the new black hole never come back out. They are lost forever. This creates a very specific signature called the ring down. After the peak of the chirp, the merger, the signal should cut off abruptly. It should vibrate for a split second as the new hole settles down, and then silence. Absolute, flatline silence. This silence is the signature of the event horizon. It is the sound of no return. It is the sound of a bell made of mud. You hit it, and it goes thud, and then nothing. It absorbs the energy. For years, this is what physicists expected to see in the LIGO data. A chirp, a merger, and then a clean, dead silence. This silence would prove that the event horizon exists. It would prove that the holes are empty. It would prove that we are right. But what if the silence is not empty? What if, after the crash, in the dark quiet where nothing should be, we hear something else? What if the bell isn't made of mud? What if it rings? So, if a black hole is a bell made of mud that goes thud and falls silent, what is a gravastar? This is where the physics of the solid shell changes the game completely. When two gravastars collide, they do not just swallow each other, they smash together. Think about the violence of that event. You have two spheres, each containing the mass of 1 million suns, each made of the hardest material in the universe, slamming into each other at half the speed of light. Because they have physical surfaces, they cannot simply merge quietly. They ring. The collision sends a shockwave through the fabric of space-time that is fundamentally different from the signal of a black hole. Instead of a quick ring down, followed by silence, a gravastar merger produces a resonance. The gravitational waves generated by the crash travel inward, toward the core. In a black hole, these waves would fall into the singularity and vanish. But in a gravastar, there is no singularity. There is a wall of Bose-Einstein Condensate and a core of dark energy. The waves hit this internal barrier and bounce back. They reflect. Then they travel outward to the light ring, the gravity trap around the star, and bounce back in again. They are trapped in a cavity. The star literally vibrates. It resonates like a gong that has been struck by a cosmic hammer. This phenomenon is called Gravitational Echoes. It implies that the object continues to emit pulses of gravitational energy long after the collision is over. It screams. It echoes into the dark. If we are listening to the sky, we should not hear a single chirp and then silence. We should hear a chirp and then a series of repeating, fading pulses. Chirp. Can you imagine the sound of a city-sized bell ringing in the vacuum? This is the crucial distinction. A hole cannot echo because it has no bottom. A solid object must echo because it has a structure. So the question we have to ask the data is simple but terrifying. Is the universe silent after a crash, or does it answer back? If we hear even a single faint echo in the noise, the black hole theory is dead. The silence of the event horizon would be proven false. We would be living in a universe of bells, not pits, and we would have to face the fact that the monsters are solid. To truly understand why this echo is the smoking gun, you have to understand the specific acoustics of a gravastar. It is not just a simple reflection, it is a complex trap for energy. In physics, we call this a potential well. Imagine you are standing on the edge of a massive canyon, the Grand Canyon. You shout into it. The sound waves travel down, hit the canyon floor, bounce off the walls, and eventually come back to you. You hear, hello, hello, hello. That is an echo. It proves that there is a floor, and there are walls. Now, imagine you are standing at the edge of a bottomless pit. You shout, "Hello!" The sound travels down, and down, and down. It never hits a bottom. It never comes back. You hear nothing but the wind. That is the black hole model. The event horizon is a one-way membrane. Information goes in, nothing comes out. But the Gravastar model constructs a resonant cavity between the potential barrier of gravity and the hard surface of the shell. When the waves are trapped in this cavity, they bounce back and forth, leaking out a little bit of energy each time they hit the barrier. These leaking waves are what we detect as echoes. The time delay between these echoes, the silence between the hellos, tells us exactly how big the object is and where the surface is located. It is essentially a form of cosmic sonar. Submarines use sonar to map the ocean floor. We are using gravitational sonar to map the floor of the black hole. If there is a flaw, we will see these repeating spikes in the LIGO data. And here is the nightmare scenario for the mainstream physicists. If the echo exists, it means the event horizon does not. You cannot have both. You cannot have a bottomless pit that also has a flaw. It is a binary choice. Either the waves disappear forever, or they bounce back. There is no middle ground. So every time we turn on the LIGO detectors, we are effectively shouting into the abyss, and waiting to see if the abyss shouts back. And if it does, it means the abyss is actually a wall. Are you ready to hear the voice of the monster? Or would you prefer the comfortable silence of the empty pit? For a few years, this was all just theory, a mathematical ghost story. But then came August 2017. The LIGO detectors picked up a signal known as GW170817. Officially, this was classified as a merger between two neutron stars. It was a historic event, celebrated by astronomers worldwide. But while the champagne was popping, a group of researchers from the University of Waterloo, Niayesh Afshori, Jahed Abedi, and Hannah Dakar, decided to look closer at the data. They didn't just look at the main crash, they looked at the noise that came after it. Most physicists throw this noise away, assuming it is just static from the instruments or vibrations from passing trucks on Earth. But Afshori's team applied a specific filter to look for the signature of gravitational echoes, and they found something. Buried in the static, exactly where the Gravastar equations predicted it would be, was a pattern, a repeating signal, an echo. They calculated the statistical significance of this finding. It was 2.5 sigma. In plain English, that means there was roughly a 99% chance that the signal was real, and not just a random fluctuation. 99%. Let that number sink in. If you went to a doctor and he told you there was a 99% chance you had a bomb inside your chest, would you ignore him? Would you call it noise? This paper sent a shockwave through the theoretical physics community. It was the first tentative, blurry photograph of the monster. It suggested that the object we saw crashing was not a black hole, and maybe not even a standard neutron star, but something more exotic. Something with a surface that reflects gravity. The echoes were faint, yes. They were on the edge of what our machines can detect. But they were there. It was as if someone had knocked on the door of reality, and for a brief second, we heard the knock. But instead of opening the door, the scientific community locked it. Why? Why did this discovery not make the front page of every newspaper in the world? Why are we still teaching kids about event horizons when the data is whispering that they might be fake? The reaction to the echo discovery reveals a lot about how science actually works, and it is not the clean, objective process you think it is. Science is a human endeavor, and humans are terrified of being wrong. When Afshori and his team published their findings, the backlash was immediate. The mainstream community, the defenders of the standard black hole model, attacked the data. They argued that the signal was just random noise that looked like an echo. They argued that the statistical analysis was flawed. They desperately tried to wash the anomaly away. Why such a fierce resistance? Because the stakes are infinite. If Gravastars are real, then Einstein was wrong about the nature of gravity at the extreme limit. If gravastars are real, then 50 years of research on event horizons, Hawking radiation, and holographic theory goes into the trash can. Careers would be ruined. Textbooks would have to be burned. Nobel Prizes would have to be returned. The academic establishment has a massive investment in the whole. They need the whole to be real. So when data appears that suggests the whole is a wall, the immune system of science kicks in to reject the virus. They call it controversial. They call it inconclusive. They bury it in skepticism. But this is how every revolution begins. They laughed at the idea that the Earth went around the sun. They laughed at the idea of atoms. They laughed at the idea of black holes themselves when they were first proposed. Now, they are laughing at the echoes. But the data is stubborn. It refuses to go away. More papers are coming out. More anomalies are being found. The noise is getting louder. We are witnessing a civil war in astrophysics between the old guard who believe in the clean, mathematical perfection of the singularity, and the new guard who see the messy, solid reality of the Gravastar. You have to ask yourself, who do you trust? Do you trust the beautiful theory that has stood for 100 years? Or do you trust the dirty, confusing, faint signal that is trying to tell you that the universe is stranger than we imagined? Is it possible that we are censoring the truth because we are afraid of what it means? The skeptics will point to one thing to shut this conversation down. The photo. You have seen it. The famous image of the supermassive object at the center of the galaxy M87, taken by the Event Horizon Telescope. It looks like a fuzzy orange donut with a black hole in the middle. Look, they say, we took a picture of the hole. It's dark. Therefore, it's a black hole. Case closed, right? Wrong. This is the ultimate visual deception. We assume that because the center is dark, it must be empty. But simulations run by theoretical physicists, including Luciano Rezzolla, have shown that a Gravastar would produce an image that is almost identical to what we saw. Remember, a Gravastar is also a gravity well. It bends light. It creates a photon sphere, a ring of light orbiting the object. The shadow we see in the picture is not necessarily the shadow of an event horizon. It is the shadow of the gravity itself. The only difference, the only tiny clue, would be in the absolute center of the darkness. A black hole should be perfectly, absolutely black. A Gravastar, because it has a surface that might emit some thermal radiation or reflect some light, might be ever so slightly brighter. It might have a faint, ghostly glow in the middle of the donut. The problem is, our current telescopes are not sharp enough to see that difference. The image of M87 is blurry. It is low resolution. It is like looking at a coin on the surface of the moon from Earth. We can see the shape, but we cannot read the date. We are squinting at a fuzzy blob and seeing what we want to see. We want to see a black hole, so we see a black hole. But if we could sharpen that image, if we could zoom in by a factor of 10, we might see that the hole is not empty. We might see the texture of the shell. We might see the glow of the Bose-Einstein Condensate. We are building the next generation of telescopes right now. When we finally get a clear look, are we going to stare into the abyss? Or are we going to see our own reflection staring back from a black mirror? And if we do see the surface, will we be brave enough to admit that we were wrong for a century? Or will we try to paint the mirror black to keep our comfortable darkness? If we cannot trust the shadow, and if the echoes are hard to hear, is there any other way to unmask this imposter? Yes. We have to look at the skin of the object using the most reliable tool in astrophysics, spectroscopy. Every object in the universe that is made of normal matter, stars, planets, gas clouds, even you, leaves a fingerprint in the light it reflects or emits. This fingerprint is called a spectrum. When light hits an atom, the electrons jump between energy levels, absorbing specific colors of light. It is a chemical barcode. If we look at a white dwarf or a neutron star, we see these lines. We see iron. We see hydrogen. We see carbon. The light tells us, I am made of matter. I have a history. I have chemistry. But a Gravastar presents a terrifying anomaly. Remember, its surface is not made of atoms in the chaotic chemical sense. It is made of a Bose-Einstein Condensate, a single, unified quantum wavefront. It has no chemistry. It has no electron shells jumping up and down to create spectral lines. It is optically bald. If we were to analyze the light reflecting off a Gravastar, we would see nothing. No absorption lines, no emission lines, just a flat, featureless continuum of thermal radiation. It is a spectral ghost. This creates a profound existential horror. We are looking at an object that has mass, has gravity, and takes up space, but it refuses to speak the language of matter. It refuses to identify itself. To an astronomer, this is like looking at a person who has no DNA. It suggests that the object is not a part of the natural evolution of the periodic table. It is an intruder, a glitch. So the question we must ask when we point our spectroscopes at the center of the galaxy is this: are we seeing the messy, complex chemical signature of crushed matter, or are we seeing the terrifying, smooth silence of a quantum wall? If we find an object that is heavy but chemically blank, we have found the monster. It is hiding by being featureless. It is the blank face in the crowd that signals the assassin. We have been talking about these objects as if they are distant curiosities, but the horror hits home when you realize where the biggest one is located. Every galaxy, including our own Milky Way, revolves around a supermassive anchor point. In the center of our galaxy, 26,000 light-years from where you are sitting right now, lies Sagittarius A. It is a behemoth. It contains the mass of 4 million suns crushed into a space smaller than the orbit of Mercury. For decades, we have comfortably labeled it a supermassive black hole. We think of it as a giant, sleepy drain that holds the galaxy together. But if the Gravastar theory is correct, Sagittarius A Ors is not a drain. It is a bomb, a supermassive Gravastar. Think about the scale of that weapon. You have a shell of Bose-Einstein condensate the size of a solar system. Inside that shell is a bubble of dark energy with the explosive potential of 4 million stars. This is not just a hazard, it is a structural threat to the entire galaxy. We are literally orbiting a giant, pressurized container of anti-gravity. It is the heart of the Milky Way, but it is a heart made of poison. If this shell were to crack, if a star crashed into it the wrong way, or if the internal pressure fluctuated, the resulting explosion would not just be a supernova. It would be a hyper-expansion event. The dark energy would be released. The core of the galaxy would turn into a quasar of repelling force. It would sterilize the inner solar systems. It would scramble the orbits of the spiral arms. We like to think of the galactic center as a stable anchor, a heavy stone that keeps us from flying away. But what if the stone is actually a grenade? What if the only reason we are alive today is that the pin hasn't been pulled yet? Does it make you dizzy to think that the sun, the earth, and your own body are currently dancing in a wide circle around a loaded weapon of mass destruction? We are not living in a peaceful kingdom. We are living in a demilitarized zone around a sleeping dragon. Where did these things come from? The standard story says black holes are formed when massive stars die. They are the corpses of the fallen. But there is a flaw in that story. We see supermassive objects in the very distant, very young universe. Quasars that existed only a few 100 million years after the Big Bang. There was simply not enough time for stars to be born, live, die, and merge to form objects that huge. The timeline does not fit. The black holes are too big, too early. The Gravastar theory offers a disturbing alternative. They are not corpses. They are shrapnel. The hypothesis of primordial Gravastars suggests that these objects were not born from stars at all. They were forged in the fires of the Big Bang itself. In the first fraction of a second of creation, the universe was a chaotic, boiling soup of plasma. The density fluctuated wildly. Some pockets of the vacuum were squeezed so hard by the expansion that they underwent the phase transition instantly. They froze. While the rest of the universe cooled down to become gas and stars and planets, these pockets remained locked in the high-energy state. They are fossils of the creation event. This implies that the universe was born with a disease. It did not start clean and then develop black holes later. It was born spotted with these pockets of dark energy. They are the original sins of the cosmos. This changes our view of them entirely. They are not the end of a star's life. They are older than the stars. They are alien structures that have been floating through the dark since before the first atom was formed, waiting for gravity to pull galaxies around them. We are the newcomers here. They are the ancient, silent watchers. Does it not feel like we are walking through a graveyard that was full before we even arrived? We are building our homes on a battlefield that is littered with unexploded ordnance from the war of creation. The horror of the Gravastar extends beyond the individual monsters. It might explain the single biggest mystery in cosmology: dark matter. When we look at galaxies, we notice something impossible. They spin too fast. The visible matter, the stars and gas, does not have enough gravity to hold the galaxy together at that speed. They should fly apart. To fix this, scientists invented dark matter, an invisible ghost substance that makes up 85% of the mass of the universe. We have been looking for particles of dark matter for 50 years. We have built detectors deep underground. We have smashed atoms at CERN. We have found nothing. Zero. Not a single particle. Why? Maybe because it is not a particle. Maybe it is a swarm. The Gravastar theory allows for the creation of micro-gravastars, little bubbles of vacuum energy, the size of a proton but with the mass of a mountain, or the size of a marble with the mass of an asteroid. If the early universe produced trillions of these tiny, invisible, solid objects, they would act exactly like dark matter. They would be heavy. They would not emit light. They would pass through normal matter without interacting much. But they would be real. Physical objects. This is the macro-dark matter hypothesis. It implies that we are not swimming in a sea of ghost particles. We are swimming in a sea of invisible bullets. The space around you right now could be filled with tiny gravastars, zipping through the solar system, passing between the planets. If one of them hit Earth, it would pass straight through like a bullet through a cloud. But its gravity would cause havoc. It puts a physical face on the ghost. We are not dealing with a mystical ether. We are dealing with a universe that is cluttered with solid debris. It makes the cosmos feel claustrophobic. It is not empty space, it is a junkyard. And we are blind to the junk until we crash into it. Does the idea that the invisible glue of the universe is actually a swarm of trillions of tiny bombs make you feel more secure? Or does it make you want to check the math again? There is one final flaw in the design of a Gravastar that turns it from a passive threat into an active one. Everything in the universe spins. Stars spin, planets spin, galaxies spin. Conservation of angular momentum guarantees it. So, Gravastars must spin too. But here's the problem. A Gravastar does not have an event horizon to hide its rotation. It has a physical surface, and general relativity dictates that when a massive object spins, it drags space-time around with it. This is called frame dragging. Around a spinning Gravastar, there is a region called the ergo region, where space is being whipped around faster than the speed of light. In a black hole, this is fine. The energy falls into the hole. But a Gravastar is a closed box. It has no drain. This leads to a catastrophic instability known as the ergoregion instability. Waves of light and gravity get trapped in the spinning whirlpool of space outside the shell. They bounce off the hard surface, gain energy from the spin, bounce back, gain more energy, and amplify. It is a runaway feedback loop. It is like placing a microphone next to a speaker, but the speaker is the size of a sun. The energy builds up exponentially. Eventually, the friction of space-time becomes too much. The Gravastar cannot hold its spin. It has to break. And the only way to break is to dump that energy. A spinning Gravastar should act like a cosmic sprinkler, spraying high-energy radiation and gravitational waves in all directions as it tries to slow down. It implies that these objects are not stable, eternal tombs. They are temporary. They are decaying. And like a spinning top that starts to wobble before it falls, a Gravastar that loses its spin might lose its structural integrity. If the spin is what helps hold the shell up against gravity, what happens when it stops? Does the shell crack? Does the bomb go off? It suggests that every rotating Gravastar is a bomb with a timer. The timer is set by the speed of its spin, and we have no idea how much time is left on the clock for the monster at the center of our galaxy. Is it winding down? Is it getting ready to dump its energy? Or has the process already started, and we are just mistaking the radiation for starlight? We have established that rotating Gravastars are theoretically unstable. They suffer from the erga region instability, meaning they should be leaking energy and slowing down. But this leads to a disturbing observation. We see objects in the sky, like the supermassive giant in M87 or our own Sagittarius A, that have been spinning for billions of years without falling apart. They seem stable. They seem permanent. How is this possible if the math says they should be exploding? This paradox suggests that we are missing a piece of the puzzle, and that missing piece might be the scariest variable of all. In physics, there is a concept called metastability. Imagine a boulder perched on top of a hill. It is not stable. Gravity wants to pull it down. But if you dig a small dip in the top of the hill and rest the boulder there, it will stay put. It looks stable. You can push it and it rocks back. You can kick it and it stays. But it is not truly stable. It is metastable. It is waiting for a push that is just big enough to knock it out of the dip and send it crashing down the mountain. The stability of the Gravastar might be exactly like that boulder. The quantum pressure of the shell and the Casimir effect are the tiny dip keeping the monster contained. They are holding back the catastrophic instability just enough to keep the star from detonating today. But today is not forever. This implies that the entire population of supermassive objects in our universe is living on borrowed time. They are not eternal pyramids built to last until the end of days. They are balancing acts. They are spinning tops that haven't lost enough momentum to wobble yet. But what happens when they do? What happens when the boulder gets pushed just a little too hard by a collision with another star, or by a fluctuation in the vacuum energy? We might be looking at a galaxy filled with dormant volcanoes that are all chemically programmed to erupt at the same time. Are we mistaking a long fuse for a dud bomb? Just because it hasn't blown up in the last billion years doesn't mean it won't blow up in the next 5 minutes. In a metastable system, safety is an illusion that lasts right up until the moment of catastrophe. To understand the true magnitude of the explosion we're talking about, we have to look deeper into the core. I told you it was filled with dark energy. But in theoretical cosmology, dark energy is just a label. We don't really know what it is. However, the behavior of Gravastars suggests it might be a specific, virulent type of dark energy known as phantom energy. To explain this, we have to look at the equation of state, represented by the letter W. For normal matter, like rock or gas, this number is positive. For a vacuum that causes a standard expansion, W is equal to -1. This is the vanilla dark energy. It pushes things apart at a constant rate. But if the shell of a Gravastar is compressing the vacuum, concentrating it and stressing it, it might drive the value of W below -1. This is phantom energy. And phantom energy is a nightmare. Unlike normal dark energy, which stays constant as the universe expands, phantom energy gets stronger. It grows in density. It becomes more aggressive over time. If Gravastars are factories for phantom energy, they are not just batteries. They are reactors that are running hot. They are brewing a substance that defies the conservation of energy. Inside that shell, the repulsive force is not just sitting there. It is multiplying. It is getting angrier. This changes the nature of the threat completely. We are not just worried about the shell cracking and releasing a bubble of vacuum. We are worried about the shell cracking and releasing a substance that eats space-time. Phantom energy is a runaway effect. If it escapes the containment of the star, it could trigger a chain reaction that tears apart not just the galaxy, but the atomic bonds of matter itself. We are orbiting tanks filled with a solvent that dissolves reality, and we are betting our lives that the tanks won't leak. But does a tank made of math last forever against an acid that gets stronger every second? Now, let's zoom out from the single star to the entire cosmos. There is a massive mystery in modern physics that was awarded the Nobel Prize in 2011, the accelerating expansion of the universe. We know the universe is getting bigger, but for a long time, we thought gravity should be slowing it down. We thought the gravity of all the stars and galaxies would pull things back together. Instead, we found the opposite. The expansion is speeding up. Something is pushing the galaxies apart faster and faster every day. We call this force dark energy, but we have no idea where it comes from. It just seems to be everywhere. But look at the timeline. The acceleration didn't start at the Big Bang. For the first few billion years, gravity was winning. The universe was slowing down. Then, about 5 to 7 billion years ago, something changed. The acceleration kicked in. Why then? What happened 7 billion years ago? Here is the chilling connection. That is roughly the time when the first generation of stars died and formed the first massive population of black holes. Or, if we are right, Gravastars. Do you see the correlation? The universe starts filling up with these bubbles of dark energy, and suddenly, the universe starts expanding faster. Is it a coincidence, or is it a mechanism? The Gravastar theory suggests that these objects are not just passive residents of the cosmos. They are the engines of its shape. They are the source of the dark energy. By locking vacuum energy inside these shells, they might be coupling with the fabric of space-time, driving the expansion from the inside out. We tend to think of stars as tiny dots in a vast void, too small to affect the whole picture. But if there are quintillions of them, and each one is a pump pushing against the vacuum, they become the gears that move the machine. This implies that the death of stars is what kills the universe. Every time a star collapses and becomes a Gravastar, it adds another drop of fuel to the fire that is blowing the cosmos apart. We are not just observers of the expansion. Our stellar evolution is the cause of it. We are building the machine that destroys us. If Gravastars are indeed the engines of dark energy, where does the road end? What happens if the engines keep running? The destination is a theoretical apocalypse known as the Big Rip. This is the ultimate consequence of phantom energy taking over. As the repulsive force grows, it stops just pushing galaxies apart. It starts pushing everything apart. First, it overcomes the gravity of galaxy clusters, and the Milky Way is flung away from Andromeda into isolation. The night sky becomes empty, but the force keeps growing. Eventually it overcomes the gravity holding the galaxy together. The Milky Way dissolves. Stars drift away into the dark. Then, the force enters the solar system. It pushes Earth away from the sun. The planet freezes. Then, it hits the planet itself. The gravity holding Earth together is overpowered by the vacuum pressure. The planet explodes. But it doesn't stop there. In the final fractions of a second, the phantom energy overcomes the electromagnetic force and the strong nuclear force. Atoms are ripped apart. Electrons are stripped from nuclei. Protons are shredded into quarks. The universe ends not with a bang, and not with a whimper, but with a tearing sound. Every single point in space is torn away from every other point. Reality becomes a collection of lonely, isolated particles that can never interact again. This is the fate that the Gravastars are driving us toward. They are the factories producing the pressure that will eventually shred your atoms. We usually think of the end of the world as a chaotic event, fire, collision, destruction, but the Big Rip is a cold, mathematical dismantling of existence. It is the ultimate loneliness. And if the Gravastar theory is correct, the machines building this future are already here. humming quietly in the dark, doing their job. Every time you see a black hole merger in the news, you're watching the engine rev up. You are watching the accelerator being pressed down a little harder. Does it make you look at the stars differently, knowing they are the spark plugs of our execution? But there is a scenario even faster and more terrifying than the Big Rip. The Big Rip takes billions of years. It gives us time to say goodbye. But the physics of the Gravastar shell suggests a different kind of ending, one that happens instantly. Remember the phase transition? We said the shell is made of vacuum that has frozen into a solid state, like ice. In fiction, the author Kurt Vonnegut wrote about a substance called Ice-9, a special type of water crystal that was solid at room temperature. If you dropped a single crystal of Ice-9 into the ocean, it wouldn't just melt. It would act as a seed. It would teach the water molecules around it to freeze. The entire ocean would turn to solid ice in a flash. The Gravastar is a cosmic crystal of Ice-9. It is a piece of different vacuum sitting in our normal vacuum. Physics tells us that our current vacuum might be metastable. It is not in its lowest possible energy state. It is like water waiting to freeze. All it needs is a seed. All it needs is a nudge to remind it that a lower energy state exists. A Gravastar shell is that nudge. It is a region where the vacuum has already collapsed into a lower state. If the shell of a Gravastar were to become unstable and expand, not explode but grow, it could trigger a phase transition in the space around it. The solid vacuum would propagate. A bubble of true vacuum would expand outward from the star at the speed of light. Inside this bubble, the laws of physics would be different. Chemistry would be impossible. Matter as we know it could not hold together. This wall of new physics would expand across the universe, rewriting the laws of reality as it went. You would never see it coming. It travels at the speed of light, so the light from the wall hits you at the exact same moment the wall destroys you. One moment, you are reading this sentence. The next moment, you are something else. Something dead. This is the danger of keeping these frozen crystals in our universe. They are seeds of a different reality, waiting to germinate. And if one of them starts to grow, it will turn the entire ocean of space into ice. Are we sure that the ice isn't already spreading? We have established that rotating Gravastars are theoretically unstable. They suffer from the Ergoregion instability, meaning they should be leaking energy and slowing down. But this leads to a disturbing observation. We see objects in the sky, like the supermassive giant in M87 or our own Sagittarius A, that have been spinning for billions of years without falling apart. They seem stable. They seem permanent. How is this possible if the math says they should be exploding? This paradox suggests that we are missing a piece of the puzzle, and that missing piece might be the scariest variable of all. In physics, there is a concept called metastability. Imagine a boulder perched on top of a hill. It is not stable. Gravity wants to pull it down. But if you dig a small dip in the top of the hill and rest the boulder there, it will stay put. It looks stable. You can push it, and it rocks back. You can kick it, and it stays. But it is not truly stable. It is metastable. It is waiting for a push that is just big enough to knock it out of the dip and send it crashing down the mountain. The stability of the Gravastar might be exactly like that boulder. The quantum pressure of the shell and the Casimir effect are the tiny dip keeping the monster contained. They are holding back the catastrophic instability just enough to keep the star from detonating today. But today is not forever. This implies that the entire population of supermassive objects in our universe is living on borrowed time. They are not eternal pyramids built to last until the end of days. They are balancing acts. They are spinning tops that haven't lost enough momentum to wobble yet. But what happens when they do? What happens when the boulder gets pushed just a little too hard by a collision with another star, or by a fluctuation in the vacuum energy? We might be looking at a galaxy filled with dormant volcanoes that are all chemically programmed to erupt at the same time. Are we mistaking a long fuse for a dud bomb? Just because it hasn't blown up in the last billion years doesn't mean it won't blow up in the next 5 minutes. In a metastable system, safety is an illusion that lasts right up until the moment of catastrophe. To understand the true magnitude of the explosion we're talking about, we have to look deeper into the core. I told you it was filled with dark energy, but in theoretical cosmology, dark energy is just a label. We don't really know what it is. However, the behavior of Gravastars suggests it might be a specific virulent type of dark energy known as phantom energy. To explain this, we have to look at the equation of state represented by the letter W. For normal matter, like rock or gas, this number is positive. For a vacuum that causes a standard expansion, the W is equal to -1. This is the vanilla dark energy. It pushes things apart at a constant rate. But if the shell of a Gravastar is compressing the vacuum, concentrating it, and stressing it, it might drive the value of W below -1. This is phantom energy. And phantom energy is a nightmare. Unlike normal dark energy, which stays constant as the universe expands, phantom energy gets stronger. It grows in density. It becomes more aggressive over time. If Gravastars are factories for phantom energy, they are not just batteries. They are reactors that are running hot. They are brewing a substance that defies the conservation of energy. Inside that shell, the repulsive force is not just sitting there. It is multiplying. It is getting angrier. This changes the nature of the threat completely. We are not just worried about the shell cracking and releasing a bubble of vacuum. We are worried about the shell cracking and releasing a substance that eats space-time. Phantom energy is a runaway effect. If it escapes the containment of the star, it could trigger a chain reaction that tears apart not just the galaxy, but the atomic bonds of matter itself. We are orbiting tanks filled with a solvent that dissolves reality, and we are betting our lives that the tanks won't leak. But does a tank made of math last forever against an acid that gets stronger every second? Now, let's zoom out from the single star to the entire cosmos. There is a massive mystery in modern physics that was awarded the Nobel Prize in 2011, the accelerating expansion of the universe. We know the universe is getting bigger, but for a long time, we thought gravity should be slowing it down. We thought the gravity of all the stars and galaxies would pull things back together. Instead, we found the opposite. The expansion is speeding up. Something is pushing the galaxies apart faster and faster every day. We call this force dark energy, but we have no idea where it comes from. It just seems to be everywhere. But look at the timeline. The acceleration didn't start at the Big Bang. For the first few billion years, gravity was winning. The universe was slowing down. Then, about 5 to 7 billion years ago, something changed. The acceleration kicked in. Why then? What happened 7 billion years ago? Here is the chilling connection. That is roughly the time when the first generation of stars died and formed the first massive population of black holes. Or, if we are right, Gravastars. Do you see the correlation? The universe starts filling up with these bubbles of dark energy, and suddenly the universe starts expanding faster. Is it a coincidence? Or is it a mechanism? The Gravastar theory suggests that these objects are not just passive residents of the cosmos, they are the engines of its shape. They are the source of the dark energy. By locking vacuum energy inside these shells, they might be coupling with the fabric of space-time, driving the expansion from the inside out. We tend to think of stars as tiny dots in a vast void, too small to affect the whole picture. But if there are quintillions of them, and each one is a pump pushing against the vacuum, they become the gears that move the machine. This implies that the death of stars is what kills the universe. Every time a star collapses and becomes a Gravastar, it adds another drop of fuel to the fire that is blowing the cosmos apart. We are not just observers of the expansion, our stellar evolution is the cause of it. We are building the machine that destroys us. If Gravastars are indeed the engines of dark energy, where does the road end? What happens if the engines keep running? The destination is a theoretical apocalypse known as the Big Rip. This is the ultimate consequence of phantom energy taking over. As the repulsive force grows, it stops just pushing galaxies apart. It starts pushing everything apart. First, it overcomes the gravity of galaxy clusters, and the Milky Way is flung away from Andromeda into isolation. The night sky becomes empty, but the force keeps growing. Eventually it overcomes the gravity holding the galaxy together. The Milky Way dissolves. Stars drift away into the dark. Then, the force enters the solar system. It pushes Earth away from the sun. The planet freezes. Then, it hits the planet itself. The gravity holding Earth together is overpowered by the vacuum pressure. The planet explodes. But it doesn't stop there. In the final fractions of a second, the phantom energy overcomes the electromagnetic force and the strong nuclear force. Atoms are ripped apart. Electrons are stripped from nuclei. Protons are shredded into quarks. The universe ends not with a bang, and not with a whimper, but with a tearing sound. Every single point in space is torn away from every other point. Reality becomes a collection of lonely, isolated particles that can never interact again. This is the fate that the Gravastars are driving us toward. They are the factories producing the pressure that will eventually shred your atoms. We usually think of the end of the world as a chaotic event. Fire, collision, destruction. But the Big Rip is a cold, mathematical dismantling of existence. It is the ultimate loneliness. And if the Gravastar theory is correct, the machines building this future are already here, humming quietly in the dark, doing their job. Every time you see a black hole merger in the news, you're watching the engine rev up. You're watching the accelerator being pressed down a little harder. Does it make you look at the stars differently, knowing they are the spark plugs of our execution? But there is a scenario even faster and more terrifying than the Big Rip. The Big Rip takes billions of years. It gives us time to say goodbye. But the physics of the Gravastar shell suggests a different kind of ending. One that happens instantly. Remember the phase transition? We said the shell is made of vacuum that has frozen into a solid state, like ice. In fiction, the author Kurt Vonnegut wrote about a substance called Ice-9, a special type of water crystal that was solid at room temperature. If you dropped a single crystal of Ice-9 into the ocean, it wouldn't just melt, it would act as a seed. It would teach the water molecules around it to freeze. The entire ocean would turn to solid ice in a flash. The Gravastar is a cosmic crystal of Ice-9. It is a piece of different vacuum sitting in our normal vacuum. Physics tells us that our current vacuum might be metastable. It is not in its lowest possible energy state. It is like water waiting to freeze. All it needs is a seed. All it needs is a nudge to remind it that a lower energy state exists. A Gravastar shell is that nudge. It is a region where the vacuum has already collapsed into a lower state. If the shell of a Gravastar were to become unstable and expand, not explode but grow, it could trigger a phase transition in the space around it. The solid vacuum would propagate. A bubble of true vacuum would expand outward from the star at the speed of light. Inside this bubble, the laws of physics would be different. Chemistry would be impossible. Matter as we know it could not hold together. This wall of new physics would expand across the universe, rewriting the laws of reality as it went. You would never see it coming. It travels at the speed of light. So the light from the wall hits you at the exact same moment the wall destroys you. One moment, you are reading this sentence. The next moment, you are something else. Something dead. This is the danger of keeping these frozen crystals in our universe. They are seeds of a different reality, waiting to germinate. And if one of them starts to grow, it will turn the entire ocean of space into ice. Are we sure that the ice isn't already spreading? We need to go deeper into the nature of the poison inside the shell, because dark energy is too vague a term to describe the true horror of what is happening. In cosmology, We classify energy by a number called the equation of state, represented by the letter W. For normal matter, the stuff you, me, and the Earth are made of, this number is 0. For radiation, like light, it is 1/3. For standard dark energy, the kind that gently pushes the universe apart, W is -1. This is the safe version of the vacuum. But the physics of a Gravastar shell suggests it creates a pressure cooker environment that drives this number down even further. It creates something called phantom energy, where W is less than -1. This distinction sounds like boring math, but the physical implications are apocalyptic. Standard dark energy is constant. It pushes with the same force today as it did yesterday. Phantom energy is not constant. It grows. It is a runaway feedback loop. As the universe expands, phantom energy becomes denser. It becomes more powerful. It is like a bank account with compound interest from hell. The debt doesn't just grow linearly. It doubles, then quadruples, then explodes. Inside the Gravastar, this energy is being manufactured. The shell acts as a reactor vessel, compressing the vacuum until it turns malignant. It changes the vacuum from a passive background into an active, aggressive virus. When the Gravastar eats a star, it doesn't just hide the mass, it converts that mass into this virulent phantom energy. It is actively rewriting the code of the universe from stable to unstable. Do you realize what this means? It means these objects are not just storage tanks, they are factories. They are taking the stable building blocks of reality, protons, neutrons, electrons, and processing them into a substance that wants to tear reality apart. We are looking at a scenario where the universe is allergic to its own matter, and Gravastars are the antibodies produced to dissolve it. Are we the infection? Is matter the disease that these machines were built to cure? Now, let's take that concept of the factory and apply it to the biggest mystery in the history of astronomy. In the late 1990s, astronomers discovered that the expansion of the universe is accelerating. We are flying apart faster and faster every second. For years, we have asked, where is this new energy coming from? Why did it start? Look at the timeline. It is a smoking gun that nobody wants to talk about. For the first several billion years after the Big Bang, the universe was slowing down, gravity was winning. The cosmos was trying to pull itself back together. Then, roughly 5 to 7 billion years ago, the engine switched gears. The acceleration kicked in. Why then? What happened 5 billion years ago? That is exactly the time when the first generation of massive stars finally burned out, died, and collapsed. That is the moment when the universe started filling up with black holes, or, as we now suspect, Gravastars. Do you see the causal link? It fits too perfectly to be a coincidence. As soon as the universe produced enough dead stars, the expansion started to speed up. The Gravastar theory suggests that this is not an accident. It suggests that these objects are coupling with the fabric of space-time. They are pumps. Every single Gravastar is a localized engine injecting repulsive pressure into the vacuum. When you have one, it does nothing. When you have quintillions of them scattered across every galaxy, they become a collective driving force. They are the gears that are physically stretching the canvas of reality. This changes our understanding of stellar evolution from a biological cycle into a mechanical doom. We used to think stars died so new stars could be born. Now it looks like stars die to fuel the expansion. We are the architects of our own exile. Every time a massive star collapses, it presses the accelerator pedal a little harder. We are driving toward the cliff, and we are building the engine that gets us there faster. Does it make you feel small to realize that the majestic death of a supernova is just the universe refueling its destruction machine? If Gravastars are indeed the engines of phantom energy, we need to talk about the destination. Where does this acceleration lead? If the energy density keeps growing, it leads to a specific, terrifying end state known as the Big Rip. We usually imagine the end of the world as a bang, a fire, a collision, a chaotic mess, but the Big Rip is a cold, calculated dismantling of structure. It is a surgical removal of companionship. First, the phantom energy becomes strong enough to overpower the gravity of galaxy clusters. The Milky Way is ripped away from Andromeda. The night sky becomes black as all other galaxies race away faster than light. We are alone. But the engine keeps running. The force grows. Next, it overpowers the gravity of the galaxy itself. The Milky Way dissolves. The stars are stripped from their orbits and drift into the lonely dark. Then, it enters the solar system. The repulsive force becomes stronger than the sun's grip on the Earth. The planet is flung into the void. It freezes. But the horror is just beginning. In the final hours, the phantom energy becomes stronger than the electromagnetic force and the strong nuclear force. This is the moment of true annihilation. The force penetrates your body. It rips your molecules apart. It tears electrons from their orbits. It shreds the protons in your nucleus into quarks. Finally, it tears the fabric of space-time itself. The universe ends as a soup of isolated particles that can never interact again. Every point in space is separated from every other point by an infinite distance. It is the ultimate solitary confinement. And if the Gravastar theory is correct, the machines building this future are already humming in the dark. We are not just drifting toward this, we are being pushed. Every black hole merger we detect with LIGO is a sign that the pressure is building. We are watching the gears turn. Can you imagine the loneliness of a universe where not even 2 atoms are allowed to touch? That is the future these monsters are building for us. But the Big Rip takes billions of years. It gives us time to evolve, to die, to be forgotten. There is a much faster way to die, hidden in the physics of the shell. Remember the analogy of the phase transition? We said the shell of a Gravastar is made of vacuum that has frozen into a solid state, like ice. In science fiction, there is a famous concept created by Kurt Vonnegut called Ice-9. It is a fictional form of water crystal that is solid at room temperature. The story goes that if you drop a single seed of Ice-9 into the ocean, it teaches the water molecules around it to freeze. The entire ocean turns to solid ice in a split second. The Gravastar is a cosmic crystal of Ice-9. Physics tells us that our current vacuum, the empty space we live in, might be metastable. It is like water that has been supercooled below freezing, but hasn't turned to ice yet because it hasn't been disturbed. It is waiting for a seed. It is waiting for a template. A Gravastar shell is that template. It is a region where the vacuum has already collapsed into a lower energy state. If the shell of a Gravastar were to become unstable, if 2 of them collided in just the wrong way, or if one grew too massive, it could trigger a runaway phase transition. The solid vacuum would propagate, it would grow. A bubble of true vacuum would expand outward from the star at the speed of light. Inside this bubble, the laws of physics would be completely different. The constants of nature would change. Chemistry would be impossible. Atoms would not hold together. This wall of new physics would expand across the universe, rewriting the source code of reality as it went. It would turn the ocean of space into ice. This is not a slow death. This is a formatting error. It implies that these stars are not just bombs. They are biological contaminants. They are seeds of a different, hostile reality. And we are letting them float around in our ocean, hoping they don't start the crystallization process. How confident are you in the stability of a vacuum that is sitting next to a seed of its own destruction? Let's visualize what that vacuum decay actually looks like from your perspective on Earth. This is the ultimate horror of the speed of light limit. We rely on light to warn us of danger. We see the tiger before it jumps. We see the asteroid before it hits. But in the case of a vacuum decay triggered by a Gravastar rupture, the warning signal travels at the exact same speed as the death itself. The bubble of true vacuum expands at c, the speed of light. This means the light from the wall of death reaches your eyes at the exact same instant that the wall disintegrates your atoms. You would never see it coming. You could be looking through a telescope at the very star that explodes, and you would see nothing but a calm night sky right up until the moment you cease to exist. There is no sirens. There is no news report. There is no time to hug your family. One moment, there is biology, history, love, and fear. The next moment, there is just different physics. It is the perfect crime. The universe is erased without a witness. This forces us to ask a terrifying question. Has it already happened? Is the wall of death rushing toward us right now, currently passing through the Alpha Centauri system, 4 light years away? We would have absolutely no way of knowing. We are living in a state of blind trust, assuming that the vacuum is stable, assuming that the monsters in the dark are contained. But if just one of those shells cracks, the game is over. It renders all human ambition, all our wars, and all our struggles completely absurd. We are building sandcastles on a beach, not realizing that a tsunami is already moving through the water, invisible until it breaks. Does knowing this make you want to live differently? Or does it make you feel like a ghost that just hasn't realized it's dead yet? The silence of the night sky is not peaceful. It is merely the time delay of the signal. We have talked about the wall of death moving at the speed of light, but I want you to really sit with the psychological weight of that reality. It changes the fundamental nature of our existence from a story into a gamble. Think about how we usually deal with danger. We rely on the gap between the cause and the effect. We see the lightning, then we hear the thunder. We see the smoke, then we smell the fire. We rely on the warning. It gives us a chance to prepare, to pray, or to run. But the physics of a vacuum decay triggered by a Gravastar removes that gap. It collapses the cause and the effect into a single, simultaneous event. There is no thunder. There is no smoke. There is only is and is not. This turns the entire universe into a game of Russian roulette, where the gun is pressed against the back of your head, and you cannot hear the trigger being pulled. The trigger was pulled billions of years ago in a distant galaxy, or perhaps 10 seconds ago in a nearby star system. The bullet, the wall of new physics, is already in flight. It is crossing the void right now. It is passing through the empty space between the stars, erasing hydrogen clouds, dismantling asteroids, and rushing toward our solar system. And what are we doing? We are drinking coffee. We are worrying about our taxes. We are falling in love. We are living our lives in the shadow of an executioner we cannot see. Does this make our lives meaningless? Or does it make them incredibly precise? If you knew that a sniper was aiming at you, but you didn't know when he would fire, every breath you took would feel like a theft. You would value the sensation of air in your lungs because you would know it is stolen time. The Gravastar theory suggests that we are all thieves. We are stealing moments from a universe that is trying to format us. The silence of the night sky is not a sign of peace. It is a sign that the bullet hasn't arrived yet. How long can we keep winning this game of chance? If the universe is infinite and the timeline is long, the probability of the gun going off eventually reaches 100%. We are not survivors. We are just the ones who haven't been hit yet. But there is a twist to this horror that forces us to look in the mirror. We have been looking at Gravastars as objects out there, monsters in the dark that threaten us. But some physicists, like Lee Smolin and Nikodym Poplavsky, have proposed a theory that turns the camera around 180 degrees. Look at the properties of a Gravastar again: a hard shell on the outside, a rapidly expanding vacuum on the inside, a space that is cut off from the rest of the world. Does that sound familiar? Look at our own universe. We are living in a space that is expanding rapidly, driven by dark energy. We cannot see outside our boundaries. What if the reason the inside of a Gravastar looks like an expanding universe is because it is a universe? And what if the reason our universe looks like it's expanding inside a bubble is because we are inside a Gravastar? This is the nested universe hypothesis, or the Matryoshka theory. It suggests that the Big Bang was not a magical creation event from nothing. It was the moment a massive star collapsed in a parent universe. The collapse formed a shell, and our reality is the phantom energy that filled the void inside. We are the guts of a monster. The galaxies we see around us, the stars, the planets, we are just the debris floating inside the belly of a beast that exists in a higher dimension. This completely reframes our place in the cosmos. We are not the center of creation. We are the byproduct of a stellar catastrophe in a world we can never see. We are living inside a bomb. Our dark energy, the force pushing us apart, is simply the pressure required to keep the parent star from collapsing. We are the structural support for a ceiling we cannot touch. If this is true, then the Great Wall of the universe is not just a metaphor. It is real. The edge of the observable universe is the interior wall of the Gravastar shell. If we could fly far enough, fast enough, would we hit the Bose-Einstein Condensate? Would we hear the sounds of the parent universe crashing against the outside of our shell? Or are we trapped in a soundproof cell, unaware that our entire reality is just a small, violent bubble in someone else's sky? If we accept the Matryoshka theory, that we are inside a Gravastar and that our universe contains billions of Gravastars, then we have to confront the terrifying biology of the multiverse. It implies that reality is a reproductive cycle, but it is not a cycle of love. It is a cycle of violence. In this model, a universe's purpose is to reproduce. How does it reproduce? By creating stars that collapse into Gravastars. Each new Gravastar is a baby universe, a new bubble of space-time inflating inside its parent. This means that our universe is a mother, but it is a mother that dies to feed its children. We are expanding, cooling, and ripping ourselves apart to create the conditions for black holes and Gravastars to form. We are a factory designed to manufacture new realities. And what are we? The humans. We are the bacteria living in the reproductive organs of a cosmic leviathan. We are irrelevant to the process, except perhaps as observers who can realize the horror of the situation. This evolutionary view changes the definition of success for a universe. A successful universe is not one that creates life. A successful universe is one that creates monsters. The laws of physics are fine-tuned not to make us happy, but to make stars collapse efficiently. The strength of gravity, the speed of light, the nuclear forces, they are all calibrated to ensure that stars burn out and die, creating the maximum number of offspring. We are living in a reality that is optimized for death because death is the method of birth. It is a cycle of infinite parasitism. The child eats the parent from the inside out. Our universe is eating the energy of the parent universe to expand, and the Gravastars inside us are eating our energy to grow their own internal worlds. It is a chain of cannibalism stretching down from the infinite past into the infinite future. Does it make you feel special to know that you are part of a lineage of cosmic predators? Or does it make you feel like a cog in a machine that is built to grind itself down to nothing? This realization leads to a profound sense of claustrophobia. If we are inside a Gravastar, and if the vacuum decay is coming, where do we run? The answer is nowhere. We are trapped in a mind cage. Physically, we are bound by the speed of light and the immense distances between stars. Even if we had warp drive, we couldn't escape the universe because the boundary is a wall of death. But the trap is also conceptual. Our minds are built to understand a world of cause and effect, a world of open horizons. We look at the sky and see infinity, but the science is telling us that infinity is a lie. The sky is a ceiling. The horizon is a wall. The vacuum is a minefield. We are rats in a cage that is moving through a larger cage, which is inside an even larger cage. There is no outside. Even if you could break through the shell of our universe, you would just fall into the parent universe, which is likely just the interior of a grandparent Gravastar. It is turtles all the way down. This knowledge is a form of torture. It is the realization that exploration is futile. No matter how far we go, We are just exploring the dimensions of our own prison cell. We can map the cell, we can decorate the cell, we can name the atoms in the cell, but we can never leave. Does this absolute confinement drive you to despair? Does it make you want to stop looking up? It is the ultimate cosmic horror. The realization that the vastness of space is actually a suffocatingly small box. We are buried alive in layers of geometry. The silence of the stars is not the silence of peace, it is the silence of soundproofing. We are screaming in a room where no one can hear us, because the room itself is designed to contain the noise. Is there any freedom to be found in a reality that is built like a nesting doll of bombs? So, we have reached the bottom of the well. We are trapped in a decomposing universe, surrounded by invisible minds, inside a cosmic bomb, with a wall of death racing toward us. The logical response to this information is nihilism. It is to curl up in a ball and wait for the end. It is to say, nothing matters. But I want to offer you a different path. A harder path. The path of the absurd man. The French philosopher Albert Camus famously wrote about the myth of Sisyphus, a man condemned by the gods to roll a heavy boulder up a hill for eternity, only to watch it roll back down every single time. It is a pointless, hopeless task. It is the definition of hell. But Camus ended his essay with a shocking sentence. One must imagine Sisyphus happy. Why? How can you be happy pushing a rock that will inevitably fall? Because the happiness comes from the pushing. It comes from the refusal to surrender to the gravity. Sisyphus realizes that his fate is terrible, but by accepting it and continuing to push anyway, he becomes superior to his fate. He rebels. We are Sisyphus. The Gravastar is the rock. The vacuum decay is the gravity. We know the rock will fall. We know the universe will end. We know the monsters will win. But we push anyway. We build civilizations. We write songs. We study the physics of our own destruction. Why? Because it is the only way to give the middle finger to the silent architect. The universe wants us to be passive fuel. It wants us to be silent matter. By thinking, by understanding, by screaming into the void, we are revolting. We are creating meaning in a machine that was designed to be meaningless. This is not a happy ending. It is a defiant one. Can you find the strength to look at the wall of death and smile? Not because you are safe, but because you figured out the game. The revolt is not about winning. It is about playing the game on your own terms until the clock runs out. Are you ready to push the rock? If we are truly trapped inside this nesting doll of cosmic bombs, and if the machinery of the universe is designed to grind us down into entropy, we are left with one agonizing question. What is the point of us? Why does a machine built for destruction produce an observer? This brings us to the most radical interpretation of quantum mechanics, the observer effect. Physics tells us that a system exists in a state of chaotic probability, a superposition of all possible states, until it is measured. Until a witness looks at it, reality is just a ghost. If this is true, then the Gravastar, the phantom energy, and the vacuum decay do not fully exist until someone notices them. That someone is us. We are not just victims of the architecture, we are the necessary component that makes the architecture real. Think about the implications of this. The universe spent 13.8 billion years building galaxies, cooking stars, and evolving brains just so that, for a brief, flickering moment, it could look at itself. We are the eyes of the monster. We are the glitch in the mechanism that allows the machine to feel its own operation. Without us, the Gravastar is just a silent geometrical shape floating in the void. It has no meaning. It has no tragedy. It has no size. With us, it becomes a story. It becomes a threat. It becomes the destroyer. This frames humanity not as a biological accident, but as a cosmic necessity. We are the witnesses called to the stand to testify that the universe exists. And yes, the testimony is horrific. We are witnessing a crime scene. We are seeing the universe eat itself. But the act of witnessing is powerful. It collapses the wave function. It forces the universe to decide what it is. Does this give you a sense of agency? We are the only part of this cold, dead machinery that can feel the temperature. We are the nerves of the cosmos, and even if the nerve is destined to be burned, its job is to feel the fire. We are here to validate the horror. Without our fear, the Gravastar is not scary. It is just math. We supply the fear. We supply the meaning. We are the crucial software running on this hardware of death. Let us crystallize this purpose with a final physical metaphor. I want you to imagine a candle. A candle is a fine-tuned object. It has a structure, the wax, the wick, the shape. If you looked at a candle without knowing what it was, you might think it was a statue designed to stand there forever, perfect and pristine. You might admire its stability, but the purpose of a candle is not to exist. The purpose of a candle is to burn. The universe is that candle. The Gravastars, the galaxies, the laws of physics, they are just the wax. They are the fuel. And we, life, consciousness, intelligence, we are the flame. A flame is a violent, destructive process. It eats the wax. It destroys the structure. It obeys the second law of thermodynamics perfectly by turning potential energy into useless heat and smoke. But in doing so, it creates light. It pushes back the darkness. It creates a circle of warmth where things can be seen and understood. We are the flame of the universe. We are consuming the future to create the present. And yes, the candle will eventually burn down. The wax of the galaxy will run out. The Gravastars will decay or rupture. The flame will flicker and die. The smoke will drift into the eternal night of the Big Rip. But does the inevitability of the darkness mean the flame was a mistake? No. It means the candle did exactly what it was supposed to do. It converted matter into meaning. It converted stuff into light. The tragedy of the Gravastar is that it wants to keep the wax. It wants to hoard the energy in a frozen shell. It resists the burning. We are the rebellion against that hoarding. We are burning the fuel to create art, science, love, and fear. We are using the universe up, and that is okay. We should use it up. It is there to be burned. Would you rather be a block of wax that sits in the dark forever, safe and cold? Or would you rather be a flame that dances for a moment, feels the heat, sees the room, and then vanishes? The universe chose the flame when it made you. It lit the match. Your job is not to worry about when the wax runs out. Your job is to burn as bright as you can while the wick is still holding. We have reached the end of the evidence. We started this journey with a simple question. What are the black spots in the sky? The standard story told us they were holes, gentle, empty, misunderstood portals to nowhere. But the evidence we have gathered paints a different, harder picture. We have stripped away the event horizon and found a solid wall of Bose-Einstein Condensate, harder than diamond, ringing like a bell. We have drilled into the core and found not a singularity, but a pressurized bomb of phantom energy that is expanding the universe to death. We have listened to the gravitational waves and heard the echoes of a surface that shouldn't exist. We have looked at the stability of the vacuum and found a sheet of ice-9 waiting to freeze reality. The verdict is in. The universe is not a Swiss cheese full of holes. It is a minefield full of traps. The black hole was a comfortable myth, a placeholder we used because we were afraid of the solid truth. The truth is that the cosmos is physically hostile. It is filled with objects that do not just kill you, they erase you. They are factories of entropy, engines of acceleration, and seeds of vacuum decay. You can try to unsee this. You can try to go back to the idea of wormholes and interstellar travel and magic bookshelves behind the horizon. But you know the truth now. You know that if you knock on the door of the dark, it knocks back. The silence of space is not empty. It is pregnant with a violence we are only just beginning to measure. We have indicted the universe on charges of grand deception. It hid the monsters under a cloak of darkness, but we found them. We know what they are. We know what they do. And now, we have to live with that knowledge. The universe is not a safe harbor. It is a storm, and we are sailing a paper boat right through the middle of the hurricane. So, how do you live your life on a paper boat in a hurricane? How do you go to work, pay your bills, and brush your teeth when you know that a wall of vacuum decay moving at the speed of light could erase you in the next nanosecond? Paradoxically, this terror is the source of absolute liberation. If the future is guaranteed, you can be lazy. If you know you have 50 years left, you can waste today. You can procrastinate. You can hold grudges. You can be bored. But if the future is a lie, if the cause and the effect of your death are simultaneous, then the only thing that actually exists is this specific second, right now. This breath, this heartbeat. The scarcity of time creates its value. If diamonds were as common as rocks, they would be worthless. Time is the diamond, and the Gravastar is the hammer hovering over it, ready to smash it at any random moment. This realization should cure you of boredom forever. It should cure you of hesitation. Why are you waiting to tell someone you love them? The war might be halfway here. Why are you waiting to write that book? The phantom energy is growing. The physics of the Gravastar demands that you become a member of the cult of the second. It demands that you treat the present moment not as a bridge to the future, but as the destination itself. We are usually always leaning forward, looking at tomorrow. The Gravastar forces us to stand up straight and look at today. It forces us to devour the present with the same voracious appetite that the star devours matter. Do not save anything for the swim back. There is no swim back. There is only the dive. This is the ethical conclusion of the apocalypse. Urgency, ferocity, gratitude. You are alive in a universe that is trying to kill you with exotic math. You have beaten the odds for 13.8 billion years. You are winning. Act like a winner. Eat the fruit. Kiss the girl. Staring into the abyss is fine, but don't forget to look at the view while you're standing on the edge. We have arrived at the crossroads. I have shown you the map of the minefield. I have shown you the structure of the bomb. Now you have a choice to make. It is the choice between the blue pill and the red pill. The blue pill is easy. You can close this video. You can tell yourself that this was just a scary story, a fringe theory that probably isn't true. You can go back to believing in the gentle black hole, the wormhole, the magic of the movies. You can go back to sleep in the comfortable lie that the ground is solid and the sky is safe. The universe will not blame you. Ignorance is a valid survival strategy. Most people choose the blue pill because it allows them to sleep at night. But if you're still listening to my voice, I suspect the blue pill doesn't work on you anymore. I suspect you are the kind of person who would rather be awake in a nightmare than asleep in a fantasy. You want the red pill. You want to know what is actually making the noise in the attic. You want to see the wires of the simulation. This channel is for the red pill people. We do not do comfort here. We do not do safe. We hunt monsters. We dissect the anatomy of the apocalypse because we believe that knowing the truth, no matter how cold, how hard, or how sharp it is better than living in a fog. We are building a community of witnesses. A community of people who are brave enough to stare at the Gravastar and not blink. So, here is my challenge to you. Do not just watch. Join the investigation. Look at the data. Ask the hard questions. Challenge the reality you are given. If you want to continue this descent into the rabbit hole, if you want to see what other nightmares are hiding in the equations of quantum mechanics, then you know what to do. The universe is vast, it is dark, and it is full of things that want to hurt you. But we have a flashlight. Let's go see what's out there. This brings us to the final practical question of our time together. What do we do with this information? I am asking you to subscribe to this channel, but I want you to understand that this is not a request for a metric. It is an invitation to a resistance movement. Look around you. We live in a world that is obsessed with distraction. We are bombarded every second by triviality, by entertainment that is designed to numb us, by algorithms that want to keep us asleep in the comfortable blue light of the screen. They want you to look at the ground. They want you to worry about celebrity gossip and political theatre. Why? Because a population that looks down is easy to control. A population that looks down doesn't ask difficult questions about the nature of reality. But when you look up, when you really look up at the black spots in the sky and ask, is that a hole or a bomb? You are committing an act of rebellion. You are refusing to be numbed. You are refusing to accept the simplified, Disney-fied version of the cosmos where everything is safe and understood. This channel exists for the people who are tired of the lullaby. We are building a library of the unknown. We are gathering the red pill minds who are willing to feel the vertigo of the Gravastar, the terror of the Vacuum Decay, and the awe of the phantom energy. This is a hard path. It is not easy to walk around with the knowledge that the universe is a minefield. It isolates you. It makes the normal world look fragile and fake, but you do not have to walk it alone. That is why we are here. We are the echo hunters. We are the ones listening for the ring of the bell in the dark. If you click that subscribe button, you are not just adding a channel to your feed. You are signaling to the algorithm and to yourself that you want the hard truth. You are voting for the deep end of the pool. We are going to continue this investigation. We are going to look at the paradox of consciousness. We are going to dissect the simulation theory. We are going to ask if death is a technical problem that can be solved. The Gravastar was just the first layer of the onion. There are monsters deeper down in the math that make the Gravastar look like a pet. Do you want to see them? Do you have the stomach to keep peeling back the layers of reality until we hit the bone? If the answer is yes, then welcome to the resistance. Turn on the notifications, not because you need a ping on your phone, but because you need a reminder that the world is stranger than you think. Let us be the signal in your noise. Before we part ways, I want to leave you with one final, lingering image. I want to replace the fear in your heart with something stronger. Or, go back to the simulation we ran earlier. Go back to the astronaut falling toward the Gravastar. But this time, let's change the ending. Let's imagine that you don't crash. Let's imagine that you have a suit made of magic. A suit that can withstand the heat and the impact. You slow down. You drift gently toward the surface of the monster. You hover just inches away from the Bose-Einstein Condensate. What do you see? You are floating in front of a wall of absolute, perfect blackness. It is blacker than the void of space because it reflects nothing but the distorted starlight from the rest of the galaxy. It is a mirror made of night. You reach out your gloved hand. You extend your finger, and you touch it. You are the first human being in history to touch a star. What does it feel like? It doesn't feel like rock. It doesn't feel like metal. It feels like absolute stillness. It has zero temperature. It has zero vibration. It is a surface of pure, frozen quantum order. Beneath your fingertips lies the power of 1,000,000 suns, trapped in a cage of math, screaming to get out. But under your hand, it is silent. This is the definition of the sublime. The philosopher Edmund Burke described the sublime as a feeling of delightful horror, a sense of smallness in the face of something so powerful it could destroy you, yet so beautiful you cannot look away. The Gravastar is the ultimate monolith. It is the tombstone of the old physics and the altar of the new. As you float there, touching the face of the destroyer, you realize that you are touching the boundary of human knowledge. You are touching the limit of what can be known. The black sphere fills your entire vision. It blocks out the stars. It blocks out the earth. It is just you and the wall. In that moment, do you feel terror? Or do you feel a strange, cold peace? You're standing at the end of the world, and you are still alive. You have confronted the abyss, and you found that the abyss is solid. You can push off of it. You can use it as a foundation. The universe is hard, yes. It is dangerous, yes. But it is real. And touching the real, no matter how terrifying, is the only thing that makes us truly alive. Take your hand off the wall. Look at your fingerprint left on the surface of the condensate. You have left your mark on the infinite. Now, turn around and look back at the stars. The screen is about to go dark. The video is ending. You are going to put your phone down or close your laptop. You are going to look around your room. You will see your walls, your furniture, your window. It will all look very solid. It will all look very safe. But I want you to listen. Listen to the silence in your room. Is it really silent? Or is there a hum underneath it? We now know that the vacuum of space is not empty. We know it is a pressurized ocean of energy, waiting for a seed to freeze it. We know that the gravity holding you to your chair is the same force that is trying to crush stars into singularities. We know that the light from your lamp is the same radiation that screams from the surface of the shell. You cannot unknow this. You cannot go back to the world you lived in 20 minutes ago. You are now carrying the weight of the Gravastar in your mind. This knowledge is a burden, but it is also a weapon. It destroys the illusion of the mundane. It prevents you from ever being bored again. Because how can you be bored when you know you are sitting inside a nesting doll of explosions? The story of the universe is not over. The echoes are still bouncing around the cosmos. The phantom energy is still growing. The Ice Nine is still waiting. We are just a brief flash of consciousness caught in the middle of the process. We are the flame on the candle, so burn bright. Ask questions. Doubt the silence. And remember, the only difference between a hole and a bomb is the fuse, and we are holding the match. Thank you for watching. Thank you for thinking. And until we meet again in the dark, keep listening for the echo.